test-driven development, TDD. So let's start with the typical way to start a presentation. How many of you have heard of TDD? Okay, cool. How many of you have actually used TDD? How many of you have written the tests before the production code? Oh, wow, okay. I think this is the biggest number I've seen. Cool. So, yes, before we get into that, yeah, my name is Abdulcelil Cercenazi. You can call me Jalil. I'm Syrian, from Syria. I work in TomTom. I've been working there for almost 2 years now. I'm a software engineer there. I'm very interested in software craftsmanship, mainly Java, Spring. Yeah, I do lots of talks. I have lots of articles online. I'm a very big fan of TDD, as we will explore later on. So, cool. Let's start with some history. So, who knows who is this gentleman over here? Okay. Yes. So, this guy is Kent Beck. He is one of the founders of extreme programming, XP, and as one tradition of extreme programming, they introduced TDD. Alongside TDD, they had other things like pair programming, like iteration-based work, like frequent small releases, and many other things as well. But TDD was amongst this list, and it didn't really become very popular. Like, for example, the pair programming or the iteration-based work. So we have sprints, and we have so we don't have those waterfally big releases. We have small, frequent releases. So all of those concepts they got really popular. But yeah, I guess not so with TDD. So let's yeah. And fun fact, it started in March 6, 1996, which is 1 week after I was born. So yeah, it was very nice to learn that. Okay, so let's start with this statement, which might not be very obvious. TDD isn't the same as unit testing. Unit testing is actually just writing a test, right? So you have a unit, however you define that unit is. Some people might say that the unit is a class. Some people might say that the unit is a method. Some people might say that the unit is a behavioral unit. It's a bunch of methods interacting with each other and thus giving us a behavior, and that's what we call a unit. But anyways, that's not what TDD is all about. So, what is TDD about? TDD is about letting tests lead the design and the development of our software. So it's called test-driven design. Test-driven development. But some people actually also call it test-driven design as well. So, what do? So what you're actually doing is you're designing your code from a user's perspective. You're no longer looking at your code from a producer's perspective, because usually when you sit on a code, you are the one authoring the code, right? You're the one writing the code. But when you are in a TDD mindset, at the first interaction with the problem, you are really the user of the software that is supposed to solve the problem. And this small shift, it changes a lot in how you approach the solution. So what you're basically doing is you're asking a question, which is in a form of a test, and then you yourself are answering that question in a form of a solution. And what do? You also get quicker feedback from your code rather than getting it later on production on a Friday night. And also one note that good tests, they really only express outcomes. They never specify how the solution is implemented. They only say, hey, I'm expecting this, and they don't mention anything about the details, and we will find out why in a minute. Cool. So, what is our main goal of TDD? Some people might say that, hey, we're having a good coverage, this is good, the tests are the best thing that we get from TDD, but that's not really the case. The main goal from TDD is having a good design of the code. So what do we mean by a good design? A good design has a bunch of attributes that we can look at. So the first one is modular. So the code is split into modules. So not everything is under one module. So you have, yeah. So for example, if you're solving a problem, then you have a database. you have, I don't know, something that talks to an API, you have something that does some other thing. So those things, they should live in a separate, in a separate code segment, I would say. So cohesive, what does that mean is that the code that does similar stuff needs to live beside each other. So for example, the code that interacts with the database, it shouldn't be in a different, for example, totally different package than the other code that interacts with the database. It needs to be cohesive. Separation of concerns, that's also related to cohesiveness. Each part of the code does a different thing. Abstraction. Abstraction is also a good thing that we will actually now see in the live code. And what abstraction really means is that you have the ability to change code without really having fears and doubts about breaking some other parts of the code, because everything is so well abstracted. So you remove a piece and you put a piece, so it's almost like a plugin framework. And it's loosely coupled. So as we said, you shouldn't really have any doubts about changing something in the code. So everything should be loosely coupled. So if you change something, I don't know, in the API access interface, that shouldn't break anything in the database. If that does that, then yeah, you have a problem in the design. And all that aside, tests are just a nice plus that we get on the side. Even though the name test is the very first word of the sentence, it's really just a nice plus that we get on the side. It's not the main goal. So how to do it? Who know who this guy is? Uncle Bob, yes. So what does Uncle Bob say? Uncle Bob says red, and then he says, yeah, so by red we actually are rating a failing test. So a failing test might be a test that doesn't compile, that fails on assertion, anything that really doesn't make the test go green. And then you do green. What does green mean? It means make it pass. And then what do? You refactor. Refactoring is actually, so you had the code not working, now it's working, you just take a second look at the code and see if there's anything you can improve there. One very interesting thing that I read online, and it stuck with me really, is that you first have to think. And this is actually the hardest part about doing TDD, is that you first look at your code and you say, what the hell am I trying to do here? And this is really the very important key aspect of TDD. Because you really, you're putting yourself in the user's perspective, and a user by nature isn't going to make things hard for themselves, right? So by nature, you're going to write code that is easier to be used and that is easier to be tested. Cool, so I was talking for a while now. Let's look at some code and some live coding. So I'm using IntelliJ, shout out to the JetBrains people. Yes, so we have a problem. And so we're sitting at our desk, and then the product manager comes and he says, hey, we have this new feature that we want to implement. So we have a phone, right? And we want to calculate and display this phone's charge. So this particular phone exposes its power through a JSON file. This file is located on the file's storage. For convenience reasons, it's on my desktop. So an example of this JSON file is that we have the amps here and we have the hertz here. I really know nothing about phones or how to calculate any charge. Yeah, I remembered some things and I put them in the example here, so please take it with a grain of salt. So yeah, to calculate the remaining charge of the phone, we have this beautiful equation. The current amp times 4.5 plus 1500 divided by the current hertz, and then multiplied by 100, that would give us the charge. So for example, when the amps is 1 and the hertz is 2000, then we get a charge of 75. And then when it's this, we get 76. Yeah, nothing very fancy. And then at the end, to display it on the screen, we have this native phone Kotlin interface that is called charge display, and it has this method that we will pass to the new value, and then it will show it on the screen. Cool. So let's first try to solve this problem with a non-TDD way. Let's do it the old fashioned way. Okay. DVD. Let's make a Kotlin class. Let's call it charge. Let's call it like a display charge. DVD. Yeah. By the way, Kotlin isn't my native language, so please pay attention with me. And if I make any stupid mistakes, just point them out. Cool. Display charge, not TDD. Let's go. So let's go through the problem statement one more time. Yeah, it's exposed to this JSON. JSON looks like this, and we have this equation. Cool. So what is the first thing that comes to mind? The first thing that comes to mind is reading the JSON. So let's do something like this. Display charge, let's call it. Okay, cool. Kotlin, let's say. Status JSON, and then we want to read the file. The file is right here. We're going to import the file, and then after importing the file, we need to read its text, right? And then add its cross-sets UTF-8. Cool. So now we have it as a status JSON. Cool. Now we have the data. Now we need to read from it. Okay, so now we have it as a string. We need to convert it to a map. What do you call it? Status map, for example. Then it's going to be a map string double, and then what was the name? Jackson something. Network. Value, and then the value is status JSON. Yeah, I guess that's it. Which one? Oh, okay. Cool. So now we have it as a map. What was the name of the two variables? Current amps. Let's call it like this. Current amps. And then status map. Get value. That, and then click this one out. Status map, value. This cool. Now we have the two values, and now real quick, let's copy the equation right here and start implementing it. So val, let's call it current charge. So what's that? That's current amps multiplied times. Thank you. Times by 4.5. And then what do? We add plus yeah, and then we divide, right? This one I want. We divide by current hertz. And then at the end, what do? We times 100, right? Cool. And what did we say? We have this thing over here. Let's define it right here. Let's see if I even have to do this. Charge display. Probably need to private here. Cool. Charge display. And then what do? Just do charge display, display charge, current charge. Yes. Yeah. Should be an end. Cool. Yes. And now the day is done. We have implemented our feature real quick. Product manager is happy. I'm happy. We push the code, but we have this thing that's called code coverage. It's complaining that my code isn't covered by tests. Okay, cool. Let's whatever. Let's go write some stupid tests. Yeah. Okay. Let's call it display charge, no TDD, test. Cool. And then, yeah, I made a mistake here. Whatever. And then, how do we write the test? We're going to use Jupyter, sorry, not Jupyter, JUnit. And yeah, let's go test charge display, right? And then yeah, so what do we do now? We need the instance that we're actually testing. So that's val display charge.tdd, and then display charge.tdd. Cool. Display charge.tdd. Charge display. Is it charge display?
Display charge.
Display charge. Yes. But what kind of test is this? What is this test actually doing? What are we testing here? So yeah, like I've written this test. Thus far I have been very happy, very confident with myself, and suddenly I feel lost. What am I testing here? What am I supposed to do?
Are you getting 100% code
Yeah, but if you have a review on your code, then you're going to start getting some real harsh comments there. Yeah, so how do we test this code? We really can't, and it's not a testable code. And this is really just a small scale problem. Like this is some couple of lines of code that we had here, and then we just met with this issue. So imagine like spending 1 day or 2 days or 3 days writing code in this way, and then at the end of the week you're there trying to write tests, but you really can't. And you start to bang your head against the wall, and it's really not gonna work. Yeah, so, and the code design here, so here this is hard-coded value here. The charge code is also here with the calculation code, with this also with plumbing code. Yeah, this is really some ugly code that you wouldn't want to show on your CV.
Yeah, because this is like you're now writing code as if you've never written a unit test.
Exactly, yeah. So indeed, so this is a very simple example over here. So you might say, hey, I'm a professional developer. I know that this should be a parameter. I know that this should be injected from the outside, right? So you know this stuff because this is the apparent simple stuff. But when you get really into complicated design and then things start to interact with each other, it's really not that clear anymore. And you need something to forcefully make you do the right choices without you having to count on your intuition, which might not always work. So yeah, this apparently didn't work. Let's try to do it some other way. Let's try to do it the TDD way. Cool. Then real quick, let's go here. Let's create. So with TDD, we start with this, not with the production code. So display charge, TDD, and then test. Cool. Then real quick, let's start with our tests. So first test. So here is the think phase that we talked about. So we really need to stop and think. What are we trying to do? Let's go to the specs one more time. So here we have that it's that the information is written there, and here we have an example of the file. Here we have the equation. Here we have an example. I think this is a good way to start our tests, right? So we have an example. We know what's the input. We know what's the output. This is a good candidate. So let's put it here, just to stay reminded, and then let's start. So I like, with TDD, I like to do the given, when, then approach. So you say given some conditions, when something happens, then I expect this. So let's do that real quick. So given amp is 1, and hertz is 1000. When display charge is called, then show 75. Then show 75. Cool. So now we know what we're going to do. So let's start really simple. So we want to show 75. What is the first thing that we need to have the show? We know that we want that charge display thing, that charge display interface that we had. So charge display, charge display. But this is an interface, right? This is not part of our code, and such codes should be mocked. So really, because this is an interface and it probably has its own implementation down the line, and you don't want to fetch that and see how it works. You really just want to deal with the interface. And to deal with that, what you can do is you can mock Yeah, Keto, mock, and then the class for mock. What this way the class was, it was charge display, then was it? Yeah, class Java. Cool. So now we have mock, right? And what did we say we want? We wanted to show 775. So let's verify that that mock was actually called with 75. This is the way JUnit works and Mockito works. So 75. So now we know that this test is going to fail, but you should never trust the test that you don't see failing yourself. You should always see the test fail. If it doesn't fail, yeah, then you should make it fail. Yeah, it fails because it's saying that it wasn't invoked. Cool. We know that that's expected. So this is the interface. Now what we want is actually also we want the implementation of our code. So let's start writing implementation. Charge display. And then, yeah, charge display TDD. Yeah. Okay. Yeah. Let's stay consistent. Let's call this display charge. Yes, display charge TDD, and it's going to be something like this. Right. Okay, cool, but it's complaining. We don't have such a class. Let's go make it real quick. So we do this, display charge TDD. Cool, now we have our class. And now what we want to do is that we want to call the method. So display charge TDD. What was the method called there? Yeah, I'll just display charge, and then, yeah, we don't have that method, so let's go and make it. Display charge TDD, on, yeah, cool, now we have that. So, display charge, 75, okay. And what we're expecting? We're expecting charge display to be called with 75. Let's go and create that. So we know that, yeah, so we know that this needs to be called. And how are we going to get this inside this? The only way to do that is through dependency injection. So private val, or was it val?
Why you can make it inside method? Why you can make just instance inside method?
Instance inside the method? Yeah, exactly, because what we're doing in the test is that we're actually verifying that this has been called. So how do you get a handle to this object unless you pass it from the outside? As a parameter to the method? Yeah, you can also pass it as a parameter to the method. But yeah, so I guess here you can do it with the test, but here is really when your intuition comes. You don't want to pass it to the method because it's really its place is not in the method. This is dependency injection between two classes. So yeah, it's better to have it in the class. Good point, thank you. Private val, charge display. I guess it was like that. Just correct me if I'm wrong. Okay, cool. And then charge display. So we need the least amount of code that is necessary to make the code run. So let's do this. Yeah, we need to pass this here. So let's see if the code will run. Yes, passes. Cool. Now we're done with the first test case. Let's do the second test case. This is easy.
But your test name doesn't reflect conditions. You don't pass unreachable.
Yeah, indeed, yeah. But as I said, we want to write the least amount of code to make the test run, right? And this actually makes the test pass, even though it doesn't reflect these conditions.
But why then I need to write it?
Yes, we will see now. So here so this is one single test case. Usually, it's not only suffice to have one single test case. You want to test with multiple numbers. So when you have multiple numbers, then you're enforced to actually to have the implementation in place. So if the sole purpose of this method was to only show 75, then this code here would be perfectly fine. But we know that it's not going to show only 75, right? it's going to show other numbers. So you need to have other combinations in there as well. So, yeah. So here, this is our second test case. What was our second test case? It was this. Where is the spec? Spec is here. Cool. So it should show 76 when the amps is 5 and the hertz is 2000. Cool. Should show 76. Let's see if it's going to show 76. So this is, I mean, I'm just here trying to show you that even though I'm trying to be stupid and do some stupid stuff, we will see how the framework, the TDD, will actually force me to do smart things. So yeah, this is just for demo purposes, but I don't think anyone's going to write such code. But yeah, we're just proving the concept. Cool. So this is not working. So it's very clear now that we need to have an actual implementation in place, right? So what can we do to actually implement it? To implement this, let's be smart. Let's try to be smart. Let's actually pass the numbers here, right? That should make it work. Let's see what this TDD thing is gonna do. So current charge, val current charge.
You cannot use the phone.
Oh, okay, cool. I think it's like this, right?
Yeah.
Okay, thank you. So current charge, and then let's see if the tests are going to pass. Cool, the tests pass. But this is not it, right? Because we know that this is not it. Because if we go through the specs again, we know that we need to write the numbers from somewhere, and we need to know, and we know that we need to have this calculation there, right? So we know that this is not enough. So what are we going to do? Let's go through the specs one more time. We know that we have this file over here, but this is actually part of the system itself. So we need something that is test related. So we need to have it right here on the sources, and I created it here previously just for convenience sake. So let's do it. So let's actually start by reading that file. So we know that this file is here in the resources. So how are we going to pass this inside the resources? If we think about it for a second, we can actually get the path of the file and pass it to the method. And the method is going to read it from the path. So let's do that. Resources, deposit, class Java, get resource, the name of the resource, 1 amp, 1 2000 hertz, .json, right, and then path, yes. And here we have val. Let's call it the status file path. Yes, status file path. Yes, cool. So now we have the status file path, and now we need to pass it to the method. But this method is to display the charge. So this is really not going to work. We need to have another method here. So let's call it calculate and calculate and display charge. And what did we say this is going to take? This is going to take the status file path, and this is a string, right? So cool. Here we have the path. Okay. So what was the name of the method? Yep, it was this. So display charge TTD, method, and then status file path. Yeah, we don't need this anymore. So let's do the same. So this is for one case. Let's do it for the second case. And the second case is, what did you say it was? It was 5 amps, right? So we should try 5 amps. Cool. So now this should show 75, 76. Okay, let's run them. Yeah, IntelliJ is doing very nice and saying that we should do some precautionary things here. IntelliJ. Oh yeah, thank you. Yeah, okay. this is the test code, and we already know that the resource exists, so yeah, it should be okay. So if we run it again, we should see that both fail. Wow, yeah, because nothing is being actually implemented here. So let's have some implementation. So let's steal the old implementation that we have, right? Because it's already implemented. We're really just concerned about the result. So what is this implementation doing? It's doing all the calculation over here. This is no longer hard-coded. This is here. And at the end of all, we are calling display charge, the current charge, great. And if we're lucky, we should see it go green. There's not a guarantee.
But the minimal amount of code would be column twice with the in.
Sorry?
Without the formula. The minimal amount of code to make the test pass would be just column display charge twice with an in inside of the file.
You mean here, right? Sorry.
In the implementation, yeah. Instead of the formula, just call display charge twice.
Yeah. Yeah. Well, you mean you're talking about this code here, right? Or not?
Even above.
Here?
Yeah, instead of passing the formula, just call display charge twice with the exact in, and the tests will pass.
You mean here, right?
Let's just continue.
Yeah. Okay. Let's discuss it on the questions phase. But yeah, basically, let's go. Let's look at the code implementation one more time and compare the two. So this is the code with no TDD. We see that everything is here in the same method. We have a hard-coded value over here. We have the dependency being instantiated inside the class, right? Not very cohesive, not very modular. When we look here, so in this instance, even though we were acting stupid a bit, even though we were trying to misbehave, we see that we were actually forced to write this code. And what is this code? So here we are having the dependency injected. We actually have a separation of concerns. We actually see that the display part was written first, and thus it was isolated into a function. So this might be more messier, bigger code, but just for the sake of the presentation, it's the small line of code. And we see here that actually the calculation of the result was done here in a separate method, and then we call the display charge. So we immediately see the difference between the two codes, especially in the design. And also, as we said, that as a plus, we have those nice tests over here, which are actually testing something. And they're not just calling the method and hoping that works. So this is the main difference that we see between the both. Yes, that was the talk. This is me on LinkedIn. Thank you very much.